Let's discuss how to quantify delta E, okay? So if you recall from the first law, delta E is equal to Q, the heat transferred, plus W, the work done in the process, okay? Now, we have defined W as a pressure times the change in volume, okay? So that's pressure volume work. So if you replace W in this with P delta V, then we get delta E is equal to Q plus P delta V, okay? And then what we can do is, if we create a system, and typically the type of system we tend to create is a system called a bomb calorimeter. And the reason we create this is because it's essentially a closed system. So you have the system out here, it's a closed system, and you have a little sample out here in a little bowl, and then the sample itself is in a closed system, and you ignite it. So this is filled with oxygen. You ignite the sample combusts. It tries to expand its volume, but it cannot. And all around this, you have water. It cannot expand its volume, so we keep the volume constant. So delta V is equal to 0, okay? And the water actually gains the heat. So because of the combustion that happens out here, heat is given off, okay? So Q is given off, okay? And what you experience in terms of the heat change is directly proportional to the Q. So therefore, if we apply that logic to this equation out here, since delta V is equal to 0, this entire term collapses, which means that term becomes 0. So delta E is equal to Q, which is the heat transferred from the internal vessel to the water, okay? And therefore, this is a good way to understand the delta E for a reaction or any system, because all you have to do is measure the heat change, okay? And once you measure the heat change, then you can understand that heat change, because we kept the volume constant, that heat change is actually a measure of the change in the internal energy of the system.